Hi, this is Manoj Yadav and you are watching Mechanotherapy. So guys, today we are going to discuss Varignon Theorem and its derivation. Now, Varignon Theorem is used to find out the position of resultant of parallel forces. Whenever we have some parallel forces and we have to determine the resultant, we can easily find the resultant by adding or subtracting the forces. But to find out the position of the resultant, we have to use a theorem which is called Varignon theorem. Now, Varignon theorem states that moment of a force about a point is equal to sum of moments of its components about the same point. That is, if we have a resultant force R and its components are F1 and F2, then moment of R will be equal to sum of moments of its components, that is sum of moment of F1 and moment of F2. So this is a Varignon theorem. Mathematically we can say capital R into small r equal to F1 R1 plus F2 R2, where capital R is the resultant force, F1 and F2 are its components. Small r is the perpendicular distance of line of action of resultant force from the point, and R1 and R2 are the perpendicular distances of its components. Now we will do the proof of Varignon theorem. You can see in the diagram we have the resultant force capital R and its components are F1 and F2. Now, if F1 and F2 are the components of resultant, they will form a parallelogram and capital R will be the diagonal of that parallelogram. We have taken an arbitrary point O dash. Now suppose perpendicular distance of F1 from O dash is R1. We have assumed the distance x1 equal to O dash equal to small x. Now from the figure we can say x and theta 1 is the angle, so x cos theta 1 and x sin theta 1 will be its components. So we can say x sin theta 1 is equal to R1. From the figure you can see x sin theta 1 is equal to R1. Similarly, if theta is the angle of resultant R from horizontal and theta 2 is the angle of force F2 from horizontal, then we can say x sin theta 2 equal to R2 and x sin theta is equal to small r. So we have got these three equations from these three small triangles: x sin theta 1 equal to R1, x sin theta 2 equal to R2 and x sin theta is equal to R. Now we have extended the line O dash and drawn a perpendicular on this line CD. Similarly, we have drawn perpendicular lines from B and from point A. One horizontal line and one vertical line. We have given the names to the points O, A, B, C, D, E, F, G, H. Now, moment of capital R about O dash will be equal to capital R into small r. This small r can be written as x sin theta. So we can write capital R into small r equal to R into x sin theta. Now we can rearrange this equation. So we can write R sin theta into x. Now from figure COD, we can say R is the angle and theta, R is the resultant and theta is the angle, so its components will be R cos theta and R sin theta. So R sin theta can be written as CD, so we will write CD into X. Now CD can be written as CG plus GD. Now from here we'll say OB equal to AC and OB parallel to AC. Hence their projections on vertical plane will be equal. Now the projection of OB will be HD. Suppose CD is the vertical plane and you are observing OB, so B point will lie on H and O point will lie on D. So the projection of OB is HD. Similarly, projection of AC, point C will lie at the same point C and A will lie on point G. So the projection of AC will be equal to CG. So we can say CG is equal to HD. Now putting the value of CG here, we can write HD plus GD into X. Now HD can be written as BE and GD can be written as AF. So we have written it as BE plus AF into X. Now from figure BOE, and force is F1, angle is theta 1, so components will be F1 cos theta 1 and F1 sin theta 1. So BE can be written as F1 sin theta 1. Similarly, from figure triangle AOF, we can write F2 sin theta 2 equal to AF. And so equation will be F1 sin theta 1 into plus F2 sin theta 2 into X. Now multiplying X inside, we will get F1 into X sin theta 1 plus F2 into X sin theta 2. Now this X sin theta can be written as R1 and X sin theta can be written as R2. So we will get the equation capital R into small r equal to F1 R1 plus F2 R2. This is Varignon's theorem, and this is how you will derive Varignon theorem. So this Varignon theorem is used for finding out the position of resultant of parallel forces.